Welcome to this short pre-recorded lecture where I'll be presenting on the basics of my environmental pollutant, phthalate esters. So to start things off, what are phthalate esters? They are a man-made industrial chemical that is used in the making of plastic. They're considered plasticizers, and they're based off a common chemical used in plasticizers called phthalic anhydride. They're also used in polyvinyls, acetates, and resins, or PVCs. They have a low volatility and a high molecular weight, which allows them to be very strong. They also have a low melting point and they're non-corrosive, which makes them durable and long-lasting. They have a low solubility, which means that they don't dissolve in water. They're also lipophilic, and they easily absorb into fatty tissue. These PEs are commonly used in the industrial production of plastic, and there are about 18 commercially used PEs in the plastic industry today. To understand why PEs are so common in today's plastic industry, we have to talk about how they first came into style. So, PEs first started in mass production in the 1920s as a cheap replacement for camphor wax. It soon took over the market, and it's known for its high flexibility, high electric resistivity, and its cost efficiency. It's dominated the plastic market in the last decade, and even though it's in many plastics, it's not in the labels. Examples of this have been in cosmetics like shampoo, hairspray, hair gel, and deodorant. There are two main PEs used in industry today, and they are DEHPs and DINPs. Moving on, we can see how PEs are used in almost every plastic item, with this list only being some of the materials it's found in. We have food containers, packaging materials, printing inks, plastic toys, insecticides, and many other plastic products. Here, if we take a look at the types of phthalates, we can see that there are different types used in different products. They all give plastic different properties depending on the molecular structure. We can see that it's used in fragrances, varnishes, adhesives, synthetic leather, blood bags, and plastics. So we know that PEs are the most used plasticizer, but they're also the most used synthetic organic chemical in industry worldwide. They make up 65% of plasticizer consumption, and they're used across the world despite the health concerns they're linked to. Some countries have put bans on phthalate esters while others are increasing the restrictions. An increasing environmental concern has made a push towards natural plasticizers like oils. However, a majority of plastics today still use these PEs, and they're released during the production, use, and waste disposal of our plastics. So let's discuss what happens to them once they enter the environment. Well, it's very easy for them to enter the environment, and it's done so through manufacturing, weathering, leaching, and volatilization. Since they're synthetic, they don't bioaccumulate, but they do biomagnify, which means that they're moved up the food chain through fatty tissue. Studies have shown that PE exposure is chronically toxic to living organisms, and that they are considered an endocrine disruptor. An endocrine disruptor is a substance that weakens the effects of hormones by blocking hormone receptors. This can pose a serious threat to an organism's endocrine system by messing up its hormonal sequences. This can often lead to results of abnormalities in development. All right, so when these PEs enter the environment, they often get carried into our waterways, like streams and lakes, where they will remain until they're picked up by some living organism, like a bird or fish. As we move up the food chain, we also see these PEs move up from prey to predator. The reason why we have to worry about this is because PEs can be carcinogenic, which means they can cause cancer. But they also affect the reproductive system by disturbing hormone flow. So during the manufacturing of these PEs, they can evaporate into the air, leach out of their plastic containers, and seep into the living tissue of aquatic organisms. Aquatic ecosystems are mainly at risk of PEs since they're accumulated in waterways over time. In addition to this, they're known to be liver carcinogens for rodents and fish. All right, so here's a diagram showing the basic process, how these PEs end up in the environment. They can enter waterways through ground leaching, wastewater discharge, deposition, and volatilization. Eventually, they end up going into the water where they can go through hydrolysis and biotransformation. Although they're non-biodegradable, they can turn into other toxic substances that can be absorbed into the tissue of living organisms. So we've talked about the impacts of PEs in the environment, but I think we should also ask ourselves how they impact us. They're a part of our daily lives without us even knowing it. Out of any living creature, the highest PE concentration is found in a human's breast milk. This comes from the biomagnification in our food, since fish and meat have the second highest levels of PEs. When you hear that a pregnant woman shouldn't eat seafood, this is actually one of the reasons why. We can take in these chemicals through inhalation, digestion, or skin contact. We even see similar effects on us as we do with other animals. They're shown to be linked to an interference with our sexual development. Studies have shown the side effects of PEs, with one study showing a link between premature breast development and phthalates in young Puerto Rican girls. Another study has shown a link between phthalates and house dust and increasing rates of child allergy and asthma. PEs have targeted the reproductive system by messing with our hormones, specifically estrogen and testosterone. PEs actually mimic estrogen hormones, which can inhibit the testosterone hormone. This has led to concerns over male infertility, as well as developmental issues like diabetes, breast cancer, obesity, immune dysfunction, and even more. Since they're carcinogenic to humans, they've been linked to multiple cancers, and they've been shown that they can damage the DNA in our mammary cells. Even though we've heard about how toxics in our plastic can leach from our water bottles into our water, the main source of our PEs come from the food we eat. The exposure is highest in these foods, and it's especially for risk for infants, pregnant women, and the immunocompromised. And here's a list of all the health effects associated with PEs. We can see that there's some reproductive system diseases and some neurological diseases. We also have kidney disease, respiratory disease, cardiovascular, and many more. All right, so on a lighter note, we've been managing these PEs and trying to clean them up in the environment. We can test for them by using chromatography in tissue samples. It's done through a tube where the solution separates by molecular weight, like in the picture shown. We can also use liquid and gas chromatography to test for PEs. Although we can do this quite easily, the same can't be said for cleaning them up in the environment. There's no real solution to how we can remove these PEs without filtering all the water. The best thing we can do for the environment is to use less PEs in our plastic manufacturing, and also keep a better regulation on plastic pollutants. This will greatly reduce the amount of PEs that end up in our waterways in the first place, and ultimately in our food. There are some new methods for cleaning up PEs that are being tested, like using lipase enzymes in chitin beads to absorb and degrade PEs. The lipase enzyme helps digest fats, and the beads are made from chitin, and they can absorb pollutants in the water. So, talking about the future of plastics, are there any alternatives out there? Well, many manufacturers have been making a eco-friendly switch to natural oils from plants like sunflower, coconut, and vegetable. We've also been making a switch to plasticizers not based on phthalic anhydrides like DEHTs. Many plasticizers have been noted to have toxic effects, so we've been trying to move into non-toxic plasticizers like DINCHs. They're also cheap and efficient to use. With this, we've also been seeing a switch in plastics altogether with plant-based packaging like mycelium and bamboo. We have some very durable and cost-efficient plants like bamboo, hemp, and mycelium that can be harvested and used for packaging, and they are almost the secondary plastic. So phasing out phthalates, is it possible? There has been a visible change in the past decades, but it is still overwhelmingly controlled by phthalates. So with a greater economic and environmental incentive, many manufacturers are leading to alternative PVCs and natural plasticizers. The switch to a natural plasticizer must be made with an increased economic funding towards these alternatives. Lastly, I'd like to leave off with a quote, which I think explains how we should look at the issue. It pretty much sums up that even if we're taking better measures to protect ourselves against these toxic chemicals, we're still going to be exposed to them, and so will the environment. We know that they're hazardous to our health, and to be put simply, they're really just for our convenience, not for our safety. If we're going to live in a world based upon plastic products, I think it's important that we have to look at the alternatives for plasticizers and realize that the toxic chemicals we put in are the toxic chemicals that we're going to get out. And here is my list of references from the sources I've used. And thank you very much for listening. I hope you learned something about PEs.